Hello, welcome back everybody to more on math. This is Math 1351, and today we're going to do the Chapter 9, Section 2, Multi-Stage Experiments and Modeling Games, the homework. Alright, question number 1. A box contains 3 white balls and 4 black balls. Complete the sets A and B below. Alright, A1 says, a ball is drawn at random from the box and not replaced. So this is without replacement. What that does, remember, when you do without replacement, that means it changes the number of balls in that group and the number of balls left inside the bucket or the basket. So we have to take that into consideration. Then a second ball is drawn at random from the box. Draw a tree diagram for the experiment and find the probability of the event. Alright, so let's look at the event. So this is 9.2, number 1. Alright, so we have 3 white balls and 4 black balls. Total 7 balls. So here's our initial event. So the first event, if we were to draw a white ball, the chance of getting it is 3 out of 7. On the first event, the chance of getting a black ball is 4 out of 7. That's the first draw. Remember, and this is without replacement. So now the second draw, this is the first draw. The second draw, assuming we picked the white ball in the first draw, to get a white ball in the second draw, remember we kept the ball. So we have 1 less white ball, and we have 1 less of the total ball, so it's 2 over 6. Which simplifies to 1 over 3. Now, if we drew a white ball on the first one and drew a black ball on the second one, remember there's still 4 black balls, but remember, and out of 6, so that is 2 over 3. Now let's look at the other side. If we drew a black ball on the first one, and the second event, if we drew a white ball, since we drew a black, we still have 3 white balls, and we kept that first one, so we only have 6 left. Simplifies to 1/2. Okay, if this first ball was black and the second ball was black, so we lose 1 from the black, so we have 3, and then we lose 1 from the total, so it's 3 over 6, which makes it 1/2. Very important. Notice, if we add up all of these, 3 over 7 plus 4 over 7, it equals 7 over 7, which is 1. If we add these two, 1 over 3 plus 2 over 3 is 3 over 3 is 1. 1/2 plus 1/2 is 1. So for our first answer, we're looking for the diagram that has 3 over 7 and then splits up to, so it can't be B and C. We know those cannot be right. So we'll look for 3 over 7 and 4 over 7. Those are both right. Now, next one to get a white one is 1 over 3, not 3 over 7. So it has to be A, because it goes from 3 over 7 to 1/3, to 2/3, 1/2, 1/2. So A is it. The next part of the question is the probability of an event that the 2 balls are different color. Alright, so that means if it's white in the first one, then it has to be black. So it's in that combination, we have 3 over 7 times 2 over 3. Why is it and? Why is it times? Because it's and. They've got a white ball and a black ball. So this is an and. And means multiply. So before you multiply, simplify. So the 3's cancel. We left with 2 over 7. So that's the way. But we also go black and white. So that's 4 over 7 for the first one. And then times 1/2. Whenever you multiply fractions, always simplify first. So the 2 goes in the 4. So we have 2 times 1 is 2 over 7. Since we have 2 possible events, we add the 2 answers. 2 over 7 plus 2 over 7 is 4 over 7. That's our answer. Now, why is it multiplying here and adding here? Because if we go, the progress goes from white to black. So they have to be and. So this white one and the black one and the white one. But at the end, we could have gone white, black, or we could have gone black, white. This is an or statement. Or means addition. To win this game, I can have white, black, or I can have black, white. That's why you add the 2. So the answer here is 4, 7. Next one. Suppose that a ball drawn at random from a box, it's colored recorded, the ball is put back. So B is with replacement. What that means is the number of balls in the box will always remain the same. Nothing changes. So then the second ball is drawn. Draw a tree diagram, okay? So from there, the first ball is drawn as white. Remember, we have 3 white out of 7 balls. If the first ball is black, there are 4 black balls out of 7. So that's the first event. We put the balls back. So now in the second draw, what's the possibility of getting a white ball? Since we put everything back, it's still 3 over 7. And the number of black balls are still 4 out of 7 balls in the back. Remember, if you add these 2 probabilities, they equal 7 over 7, which is 1. Add these 2 possibilities, equals 7 over 7. Alright, now, same thing with if the first ball is black, then the next one to get a white and a black ball. So it's still 3 over 7, 4 over 7. Same thing, it's equals 7 over 7, which is 1. So we're looking for 3, 7, 3, 7, 3, 7, 4, 7. Let's see if we can find that picture. So for the white one's 3 over 7, white one's 3 over 7, 4 over 7. So the answer is B. It can't be C and D because it only goes different colors one time. And that's not going to help us at all. Alright, so let's look at the probability because it wants the 2 balls are a different color. So we can go white, black. The probability of getting the first one's a white is 3 over 7, and the probability of the next one being black is 4 over 7. Nothing cancels, so we multiply. 12 over 49. Remember, when you multiply, you have to multiply top and bottom, bottom by bottom. Top by top, bottom by bottom. So for this one, it's 12 over 49. If we go black, white, as long as they're different. The first one's black, second one's white. First one's white, second one's black. So this one is 4 over 7 times 3 over 7. Nothing cancels. So multiply. 4 times 3 is 12. 7 times 7 is 49. Since these are our two possibilities, we add the two. We have a common denominator, which is 49. 12 plus 12 is 24. So there's that answer. So that answer is 24 over 49. All right, let's look at the next one. Question number 2. A box contains 7 letters as shown as arching. 1, 2, 3, 4, 5, 6, 7. What is the probability of the outcome car, these 3 letters, in that order, if 3 letters are drawn by a with replacement and without replacement? All right, so for question number 2, we have arching as the word. There are 7 letters. Remember, so since there's 7 letters, n is 7. For any probability, we have the number of times the specific event happens over n, the total number of objects. We want the word car to come out. So the first one was with replacement. So in other words, in A, it's with, and B is without. Let's do first one first. So the possibility of getting all 3 of these letters, car. Okay, how many times does C occur in the word arching? Once out of 7. We pick it, and we got a C, we put it back. How many times does A occur? Only once. Over 7. And R, also once out of 7. Remember, so the first one is a C, and the second one is an A, and the third one's an R. That's why we multiply them. So multiply them out together. 7 times 7 times 7. 7 times 7 is 49. 49 times 7 is 3. 343. That's the probability of getting a car in that order. Now without replacement, which means you keep the letters. So the probability of getting a C on the first one, it occurs 1 out of 7 times, and we keep it. So now there are only 6 letters left. A occurs only once, so it's 1 over 6, and we keep it. So now there's only 5 letters left. R appears only once, so we keep it there. Nothing cancels, multiply across. 1 times 1 times 1 is 1. 7 times 6 times 5. 6 times 5 is 30. 7 times 3 is 21 with a 0 behind it. So those are the probabilities of those events happening. So 1 over 343 and 1 over 210. All right, number 3. An executive committee consists of 12 members. 7 men, 5 women. 4 members, 7 men, 5 women, which is a total of 12 people, I'm sorry. We have 13 from. 4 members are selected at random. So we have 4 people selected. The names are drawn from a hat. What is the probability that all 4 selected are women? Okay, so the first woman is 5 out of 12. There's 5 women. She's been chosen, so there's only 11 people left and only 4 women. She's been chosen, so it's 1 less woman over 10. That lady's been chosen, so it's 2 over 9. Alright, so now, since we're multiplying, because the first one has to be a woman, and the second, and the third, and the fourth, so we're multiplying them. Before you multiply, let's simplify. 4 times 3 is 12. 5 times 2 is 10. So the top is 1. 11 times 9 is 99. So the chances are 1 out of 99 tries. All right. That's the first page. Let's look at the second page. Number 4. Assume the probability is 1/2 that a child born at any time is a girl, and births are independent, meaning the first birth doesn't affect the second birth, and the second birth doesn't affect the third, so they're all independent. What is the probability of an event that if a family has 4 children, no twins, they're all girls? Okay, so let's look at this. So we have 4 children being born. If the probability of the first one being born a girl is 1 over 2. Because it says the probability is 1/2. Now the next one being born is also 1/2. Because why 1/2? Because you have the possible outcomes. The sample space is either a man or a woman, male, female, and there's only one of those. So it's 1 woman over 2 possibilities. 1 woman over 2 possibilities. So all 4 of these events have to be girls. So multiply the top. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the probability that 4 children being born, and they're all girls, is 1 out of 16. All right, the next one. Number 5. 8 blue socks, 4 white socks, and 6 gray socks are mixed in a drawer. You pull out 2 socks, one at a time, without looking, and complete A and B. A is draw a tree diagram. Remember, we're drawing 2 socks. Here's your drawer. The first one is a blue sock. So what's the probability of a blue sock? So we know in total we have 8 blue socks out of 8 plus 4 is 12 plus 6 is 18. Okay, that simplifies. 2 goes into 8 4 times. 2 goes into 18 9 times. Probability of getting a white sock is 4 out of 18. So again, simplify it. 2 goes into 4 twice. 2 goes into 18 9 times. And the possibility of getting a gray sock. So it's 2 over 9 for that one. So for the gray sock, we have 6 over 18, which 6 goes into both of those. 6 goes into 6 once, 1 over 3. Alright, so let's look at which ones cannot be right so far. So the white one has to be 2 over 9, so it can't be that one. That one says 1/2, so it's not right. This one says 1 over 3, that one's not right, so it's either A or D. The top one is 4 over 9, 4 over 9, 1 over 3, 1 over 3. Okay, so now we look at the second draw. We get a blue sock, a white sock, a gray sock. So now the first one, is it, well, you keep it because it says without replacement. So now how many blue socks do you have? If you drew a blue sock, that means you have one less. So now you only have 7 of them. And instead of 18, you only have 17 socks left. You still have all 4 white socks, but there's only 17 left in the drawer. And you still have 6 gray socks, and there's 17 left in the drawer. Now, if the first draw was a white sock, what's the chance of getting a blue, white, or gray? So we took the white sock and we kept it. So now there's only 17 socks left. Since we drew a white sock, we still have 8 over 17 blue socks. We're 1 short of a blue sock, so it's 3 over 17. And then 6 over 17. Same with the last one, with the gray sock. So we still have 8 blue socks over 17. We still have 4 white socks out of 17. The reason being because in this draw, we drew a gray one. So now we have 1 less gray sock, so it's 5 over 17. Alright, so let's look at the possibilities. So which one has 7 over 17, 4 over 17, 6 over 17? Okay, from our picture, remember, on the second draw we should have 7, 4, 6. 7, 4, 6. Nope, nope, no. So the answer is A. Okay, that's for the first part. Now the second part. B. What is the probability of the event of getting 2 socks the same color? So of getting black or blue and blue is 4 over 9 for the first blue sock, and then 7 over 17. How about white and white? So it's 2 over 9 times 3 over 17, and then gray. It's 1/3 times 5/17. Okay, so what is the probability of getting 2 socks the same color? So in this first one we have 28, 7 times 4. 153, 28 over 153. 2 times 3 is 6 over 153. 1 times 5 is 5 over 153. So now next what we have to do? Well, we have to add those. So we have 28 over 153 plus 6 over 153 plus 5 over 153. +28 plus 11 . It's 4 over 9, 7 over 17. It's 28. Okay, so now the white one is 2 over 9, 3 over 17, 6, okay. And you have 6 of the gray ones, so 1/3 times 517. I'm just checking my numbers here. Yeah. Okay, so it's gotta be so if you look at all the possibilities and add them together. What is a probability event if 2 white socks? If 2 white socks, the probability is is 6 over 153. Alright, so let's look at the bottom here. 5 plus 3 is 8 plus 1. Since if we add up these numbers, 1 plus 5 plus 3, that equals 9. Since this number is divisible by 3, that means 153 is divisible by 3. So 3 goes in both of them. 3 goes into 6 twice. 3 goes in 153. 3 goes into 15 5 times. Subtract that, so those cancel. 3 goes into 3 once, so it's 2 over 51. And that's one. Suppose that instead of pulling out 2 socks, you pull out 4 socks. What is the probability of getting at least 2 socks the same color? Okay, remember, you only have 3 different color socks. If you draw 4 socks, so the first possibility could be any one of these, blue, white, green, or gray. And the next one, it has to be blue, white, or gray. So you'll be sure to get any of those. So it's 100%. So the probability is 1 or 100%. Alright, that does it for section 2. Alright, good luck everybody.